All right, on to lesson 3.5, and this is where 3.2, 3.3, 3.4 actually all come together to where you are learning how to sketch without a calculator. Yeah, I realize you got a calculator most all the time, but again, those of you that are going to be taking the AP Calculus exam one day or the SAT, both of those tests have components, parts that are non-calculator active. And so you have to have working knowledge about sketching functions without the calculator. So what this is all going to boil down to, you need to understand about the fundamental theorem of algebra and how many roots you're going to get based on the degree. You need to understand the turning points. You need to understand what a cubic function or a degree 3 is going to look like. Moving on, you need to understand ending behavior. Do the dance. It'll help. And then how to find the roots, because the roots will be the x-intercepts, and that's going to help you to sketch your graph. Now, let me remind you before we do anything else, let me remind you that cubic functions are generally going to look like one of these two. The mama function, if you remember, the mama function looks like that right there. And then when you take the mama function and you expand her, if she does have a transformation, expand it enough, you might end up with a function that looks like one of these two. And with cubic functions, degree 3, you have 1-2 turns. And if you think about the way it's supposed to be drawn, if you have a positive A, then a positive A is going to start low and finish high, whereas a negative A is going to start high and finish low. So this is going to finish in the first third quadrants versus the second and the fourth quadrants. So, sketching. Now again, I've got an example here. Alright, so this box here has all the information. It is, I've tried to lay it out in a step-by-step fashion so that you could follow through or follow it. So you take this particular cubic expression, you're going to factor it, GCF, X factor, in order to get the 3 roots, the 3 rational roots. And from those 3 rational roots, you're going to find the 3 x-intercepts. And then, of course, one of them being 0, 0 gives you the y-intercept itself. Degree of 3, the leading coefficient is a positive number, and just in case I didn't say this in a previous video, the leading coefficient is the coefficient in front of the variable who has the highest degree. Now, let me say that again. It is the coefficient in front of the variable who has the highest exponent. That is the highest exponent. So 2 is your leading coefficient, and because it's positive, that tells you which direction it is going to start and stop. It's going to start low and it's going to finish high, third and first quadrants. And then, of course, being a degree 3, take 1 away from that and you have 2 turning points. So, and you can also read some things that I've got here in these little starburst. A real rational root, or a real root, is a real 0, which is also called an x-intercept. And the number of turning points is 1 less than the degree. So these are things that we have learned from Math 1 and from previous lessons in this class. And here's your basic setup of a cubic function. And don't forget that if it is cubic, degree 3, if you add 1, then that tells you how many terms, T-E-R-M-S, that you should expect, where A is the leading coefficient, and D, which is your constant term, is the y-intercept. In any kind of a cubic, quadratic, quartic, quintic, any of those polynomial functions, linear as well, that number, that constant term, is always going to be the y-intercept. So, sketching this particular cubic function, well, to start with, I'm going to factor this out. Again, GCF leaves you with an x squared minus 4, which will factor to an x plus 2 and an x minus 2. And once you have your factors, then you have your roots. You got 0, you've got negative 2, and you have positive 2. Those three roots are then going to become our x-intercepts. So if I just sketch, and again, this is all it is sketching. So when I sketch this, I'm going to put dots at 0, at negative 2, and positive 2 on the x-axis. Degree 3 means I have 2 turns, two turning points. And because the 1 right here, the a value is 1, and that a value being positive means that I'm going to start low and I'm going to finish high. So if I start low, I'm going to go up. I'm going to make a turn. That is my first turn. I'm going to go back down through that x-intercept. I'm going to turn and I'm going to go back up through. So there we have our sketch. And again, here's the difference between a sketch and a graph. Graph means that I've got several points that I want to go through. Sketch means I'm going to hit the highlights. I'm going to make sure that I've got a negative x-intercept, a positive x-intercept. I'm going through the origin. I'm starting in the right place. I'm not putting any values here on the y-axis because, again, this is just a sketch, just so that you will understand what it looks like. Now we can also talk about the ending behavior, just to make sure you understand the whole ending behavior idea. If you're in the first quadrant, which is where this is going to end, everything is positive. X is positive, Y is positive. So when we are listing our end behavior, f of x, who is y, approaches positive infinity. Positive infinity. As x approaches positive infinity. So the signs on the infinity will be the same as the signs of the first quadrant. If we were in the third quadrant, f of x approaches, third quadrant, everything is negative. So negative infinity as x approaches negative infinity. So there are the end behaviors, there are the solutions, the sketch, making sure that we hit all of our x-intercepts and that we know that our y-intercept is also 0, 0. All right. And for this one, all right, now this one has obviously an x that you can pull out. So I'm going to pull an x out. But you'll also notice that all three of those are even numbers. 2 being the smallest one. So 2 is going to come out. Now, here's another rule of thumb that will help you moving forward when you're factoring in your upper level math classes. Anytime that the leading coefficient is a negative, it is a good idea to pull out a negative GCF. So negative 2x will come out. Now this one I can't go straight to the double bubble. I've got to do my DBSL work here. Divide big, subtract little. So when I divide big, that's going to be a positive 1. Subtract little, it's an x squared. Divide big here is going to make it a minus 2, x to the first. And divide big, minus 3, subtract little, the x's cancel each other out. Then, when I factor this again, double bubble. This is an easy one, so I'm not going to do the x factor. X squared locks in x times x. Two numbers that multiply to give you 3, that will subtract to give you a 2, is 3 and 1. Signs are different, and the larger of these two numbers will take that sign, minus 3 plus 1. And my roots, like I said before, if you have an x in this GCF position, I don't care what number's there, one root is 0. Opposite of the second divided by the first, opposite of the second divided by the first. So that gives me my 3 roots, which allows me to graph my x-intercepts. There's 0, there's positive 3, and there is negative 1. Now, I have to go back up here. The a was negative 2. Well, what does that mean? Well, anytime that a is a negative number, then I'm going to start high and finish low with my 2 terms. So, start high, got to make a turn, and finish low. Now, this is not beautiful. It's not a pretty graph. Again, we're just sketching. We're hitting the highlights. Start high, finish low. 1, 2 turns, 3 x-intercepts. In behavior, f of x approaches. Well, if you're in the second quadrant, the signs are negative x and positive y. So your in behavior has got to follow suit. F of x, who is y, approaches positive infinity as x approaches negative infinity. And for this particular fourth quadrant, remember it is positive and negative. It's just the complete opposite of the second quadrant. F of x approaches negative infinity as x approaches positive infinity. So there we go with our sketching cubic functions. And what you need, oh, I got 2 more, sorry, I forgot I had 2 more in the back. We'll take care of these 2. Alright, so these next 2, and yeah, we got to definitely hit these 2 because these are the ones that have the multiplicities with them. So, for this one right here, x equals, because these, if you'll notice, these are already in factored form. So these are going to be a little bit quicker. This is going to be a negative 2, but it's going to have a multiplicity of 2, which means there's going to be a balance involved. And the other one is x equals positive 5. So when we sketch this, negative 2, positive 5. So there's only going to be 2 x-intercepts. But yet, there is a degree of 3 right here. So it's still going to have the degree 3 shape. The a value, well, if you were to take x squared and multiply it to x, that's going to be a positive x cubed, positive 1x cubed. So a is actually 1. So that's going to tell me I'm going to start low, and I'm going to finish high. I'm still going to have 3 turns, and I am going to bounce off of the -2. So this is what the bounce is going to look like. So I'm going to start low. I'm going to go up to the -2, but instead of going through it, I'm going to ricochet off of it. So that's what a multiplicity is going to look like when you are graphing a cubic function. And I'm going to go down here, I'm going to turn it around, and then we're going to go back up through. So that gives me my start low, finish high, 1, 2 turns, which is what you're going to have with a degree of 3, and the ricochet or the bounce at the -2. Now, I'm not going to go back through the explanation of in behavior again, but I will write the in behavior. F of x approaches positive infinity as x approaches positive infinity. And on this side, f of x approaches negative infinity as x approaches negative infinity. Another thing that we need to talk about, and I didn't do this on the front side, but domain and range. And I'll go back to the front side and we'll talk a little bit about domain and range. For this one right here, this root is 0. This root is 4, but there's a multiplicity of 2. And the reason we write 2 here is because that number right there is 2. If that would be a 3, then I put multiplicity of 3 right there. Sketching it. All right. One x-intercept is 0. The other x-intercept is 4. 4 has the multiplicity. 4 has the bounce. This is a -a. And this is still a degree 3 because there are 2 x's and there's the third x. So with a negative leading coefficient, that means I'm going to start high and finish low. Remember, the bounce occurs right there. So I'm going to start high, I'm going to come through, turn around, I'm going to bounce or ricochet off of that 4, and that's what my sketch would look like. F of x approaches positive infinity as x approaches negative infinity. And on the flip side here, f of x approaches negative infinity as x approaches positive infinity. Now, let me go back and talk about domain and range. And domain and range, it doesn't matter if it is start low, finish high, cubic function, or the opposite. It makes no difference. The domain will always be all reals, which again we know that can be negative infinity to positive infinity. And the range, again, will always be all reals. Some things that I can go back and tell you about domain and range before I finish this out. Go back to 3.2 for a second. If I'm dealing with a constant function, my domain will always be all reals. The range won't, but the domain will. If I'm dealing with a linear function, both the domain and the range will always be all reals. Quadratic, domain, always all reals. Range won't, domain will. Cubic, domain and range will always be all reals. Quartic, because quartic and quadratic are very similar, domain, always all reals, range will not. The range will actually be determined by the absolute max or min, depending on whether it is opening up or opening down. In this case, it would have an absolute min, and that would determine what the range is. Same thing here. Absolute min would determine the range. And then quintic, domain and range, always all reals. So degree 1, 3, 5, odd degrees. The domain and the range will always be all reals. Even, which is 0 to 4, only the domain will be all reals. The range, well, it'll depend. So that's just a little something to remember. I do have 4 practice problems here, and what I want you to do is I want you to hit pause, and I'm going to hit pause, and I want you to work on this. And I'll have the sketch here, so when I resume, I will actually have the answers so that you can check. But I do want you to hit the pause button, work on these 4. They won't take you that long. And once you're finished, that's all you've got for this particular note card. All right, I am back, and I figured out that I made a boo-boo, which is not going to be unusual. I'm going to make mistakes. That 15 should have been a positive 5. So if you had trouble factoring this one, then you were right. I did something wrong. So that should have been a 5. And when you do factor it, at that point, you will find the 3 roots. So here are my factors. Here are my roots. My roots are the x-intercepts. Since the leading coefficient is 1 and positive, that means I'm going to start low and I'm going to finish high with 1, 2 turns. And again, if you want to do the end behavior, f of x approaches positive infinity as x approaches positive infinity. And in the third quadrant, f of x approaches negative infinity as x approaches negative infinity as well. Over here, 3 x-intercepts. Now this one again, here's my -1, there's my -2. So since negative 5/3 is somewhere between -1 and -2, I put it right here. This is a negative leading coefficient. So that means that I'm going to start high and I'm going to finish low with 2 turns. In behavior, f of x approaches positive infinity as x approaches negative infinity, and that's because the signs of the second quadrant are negative, positive, negative x, positive y. Fourth quadrant, if you haven't figured this out, it's complete opposite of the second quadrant. So if this is positive, this will be negative. As x approaches, that was negative, that is positive. And the domain would be all reals, and the range would also be all reals. Right. These 2 at the bottom, there are bounces involved because of the multiplicities, or this one, not this one here, but this one has a bounce. And when you factor it, factored, 3 is a root with a multiplicity of 2. -4 is the other root. -4, +3 are my x-intercepts, and the bounce is at the +3. And this in behavior would be the same as this one right here. Domain range, exactly the same. And for the last one, in behavior would be the same. The 3 roots are -3, +1, +4. You do not have a root here, and that's because there's no x there. No x, no root. So there are my 3 roots. And I will tell you, thinking back to previous tests, this is the problem that most people miss because they try to put an extra root in this. If there are only 3 x's, then that means it has to be a cubic function. And a cubic function has to have arrows pointing 1 up and 1 down. Can't go the same direction. If you ever need to do this by hand, and that is to find the y-intercepts. Now the y-intercept is when x is 0. So what would that number be? Well, if you went up here and you put 0 in for the x, and 0 the x there, this would end up negative 3 squared, which is 9, and this would be 4. So 9 times 4 would make that a positive 36. Well, that's my positive 36. Same thing over here. If I wanted to find the y-intercept without a calculator, I would put 0 in for all the x's. So that would be negative 4 times negative 1, which is 4. 4 times 3 is 12. And 12 times negative 2 would be negative 24. Well, negative y-intercept. So up here, I didn't have to worry about that because I'm running through the origin. So my x-intercept would be, my y-intercept, would be 0, 0.